In the last class, what we have seen? We have seen timer configuration and programming, and we have seen an LED blinking program where the delay for LED blinking was generated by using timer 2, right? So what you have done there, when the delay is over, UIF flag will be set, that is update interrupt flag will be set. We are continuously checking whether UIF flag is 0 or 1. If it is 0, you will be keep on waiting there, showing the timer is still continuing to count. And if it is set, we can identify that the time delay generated by the timer is over, so that we will perform the toggling of the LED. But here we can see that most of the time the CPU will be tied up in checking the UIF flag. So how can you solve that problem? That can be done using the compare mode of operation of the PWM. Yesterday we have seen timer mode of operation. Now we are going to see compare mode of operation of PWM. So what do you mean by compare mode? It is something like an alarm clock. So you will be setting a particular value in the compare register, and when the timer counter value is equal to that compare value, a particular event will be generated in the output pin. That is known as compare mode of operation of timer, right? So using that compare mode, we are going to do the same process. So how will you do that? You will be giving a particular value in the compare register. Then whenever you are getting a clock to the timer counter, it will keep on incrementing, right? And when the value of the timer counter is equal to the counter or the compare register value, what you are going to do? You are going to toggle the particular channel of timer 1, right? So this is the block diagram of the compare mode of operation. You can see that this is the timer counter register. This is known as CCR register or the compare capture compare register, and this is known as the auto reload register, right? So initially what will happen? Whatever value you are giving in the auto reload register will be compared with the counter value. That is what you have seen in the last class. When both these are equal, what will happen? Counter value will be reloaded with 0 0. When the counter value is equal to ARR, 0 0 will be loaded to counter value and UIF will be set. But here what you are going to do is, in the compare mode, the counter register value will be compared with the capture compare register. Right. Whenever these two are equal, so how will you check whether these two are equal? By using a comparator. So when these two are equal, you can configure this a particular output logic in such a way that a particular event will be generated in timer X channel Y. X stands for the timer number, Y stands for the channel number. So in the yesterday's class we have seen that most of the timers are having more than one channels. Certain timers are having maximum up to 4 channels. These 4 channels can be acting as an input or an output. It will be acting as an input in compare mode of operation. It will be acting as input in capture mode of operation, and it will be acting as output in compare mode of operation, including generation of the PWM. So when counter is equal to CCR value, we can generate a particular event in this pin. So for time being, you are going to configure it for timer 2 channel 1. Timer 2 channel 1. Right. So what we are going to do, whenever these two values are equal, we are going to toggle timer 2 channel 1 pin. We are going to toggle timer 2 channel 1. So what is the advantage? We don't need to interfere in the program by checking UIF flag or whatever flag. Once the configuration is done, it will keep on generating the signal automatically. So as you have seen in the last class, since you are using timer 2 as the time base for the compare mode of operation, whatever compare mode or capture mode or timer mode, our time base will be a timer. So here it is a timer 2, So yesterday we have seen that timer 2 is having AHB prescaler, APB1 prescaler, and the timer 2 prescaler. Right. So all those prescalars are applicable here also. Why? Because we are using timer 2. So AHB prescaler, APB1 prescaler, and here I have shown is a timer 2 prescaler. Then one timer enable signal is there. Once all the configuration is over, you need to give the timer enable signal. So how here it is working? Counter is configured in up counting mode. So counter will keep on counting from 0, 1, 2, 3, etc. when it is getting a clock. Up to what value it will keep on counting? Up to the value stored in ARR, right? So before that, each time when the counter is counting, it will be compared with the capture compare value stored in CCR register. Whenever it is equal, this pin will be toggled. And again it will keep on counting, and when the counter value is equal to ARR, as you have seen in timer 2, what will happen? Counter will be reset to 0, 0 again. That is known as update event. So this is the operation of compare mode. So what all things you need to configure here? You need to configure all the prescalars as you have seen in the timer 2 configuration. So AHB you need to configure the prescaler, APB prescaler also you need to configure. Then timer 2 prescaler you need to configure. How will you configure that? Yesterday we have seen timer X PSC register is there, right? So if you want to have a prescaler ratio 1:1, PSC should be 1 minus 1. That is prescaler ratio, that is 1:1. So but that is 1 minus 1, you need to write 0. So whatever prescaler ratio you need to have, you need to subtract 1 from that, and that value should be loaded into PSC, that is prescaler register. So always when by configuring the prescaler register, you are dividing the timer clock by PSC value, that is whatever value you have written here, plus 1. PSC plus 1 is nothing but your actual prescaler that you need to set. Then as you have seen last class, you need to configure AHB prescaler and APB1 prescaler. AHB prescaler can be from 1 to 512. APB1 prescaler, even though these many prescalars are possible, but for timer you can have only 2 prescalars, either divided by 1 or by 2. So if you are writing 1 here, APB prescaler will be 1:1. For all the other values, APB prescaler for timer alone. For timer alone, it will be by 2. Then finally, you need to configure the timer X prescaler that we have seen in last slide. So this is how you are going to calculate the delay using timer 2. This equation also we have seen last class. Delay equal to auto reload register, that is N into AHB prescaler into APB1 prescaler into timer prescaler, that is P, plus 1 into time taken for 1 clock. Here my clock is nothing but system clock. So time taken for 1 clock is 1 by system clock, right? Say let us take one example. I need to generate 1 second delay, assuming AHB prescaler and APB prescaler equal to 1, P equal to 1599, or you need to find out what value should be loaded into ARR in order to get 1 second delay. So by rearranging this equation and substituting the value of delay, system clock is 16 megahertz, delay is 1 second, AHB and APB prescalars are 1. What was P? P is given here 1599. By substituting all these values, you will get value of ARR, that is N as 10,000. This is also last class we have seen. Then now you need to find out in which port your actual timer 2 channel 1 functionality is available, right? So in one of the classes I have shown this table showing the alternate functions of port A. So here you can see that port A5 is having alternate function of timer2 underscore channel 1. Which is that for alternate function? Alternate functionality 1. For which port or which pin? PA5. So my next aim is to configure PA5 alternate functionality 1. So that PA5 will be having the functionality or configuring the functionality of PA5 as timer2 channel 1. So how will you configure the functionality of a pin? Using mode registers. Right? Using mode registers. So before configuring the functionality, what should be the first step? You need to enable the clock to which port? This is port A. So first of all, you need to enable the clock to port A. Then only you should configure the other things such as functionality and all those things. So first of all, you need to enable clock to port A. How will you do that? Last class we have seen AHB1 enable register 0th pin you need to set. By setting this, you are enabling clock to GPIOA peripheral by using AHB1 enable register. Second step is you are configuring the mode register. Which mode register you need to select? GPIOA mode register. Why? Because you are configuring the functionality of GPIOA 5th pin, that is PA5 pin. So how can you configure the functionality of PA5? You need to configure bit number 10 and 11. Combination of 2 bits are used for configuring the functionality of each pin. So 0th and 1st pin is used for configuring functionality of PA0. These two are used for configuring functionality of PA1. Like that, bit number 11 and 10 is used for configuring the functionality of PA5. You can see here, mode 5, 1:0. These 2 bits. That is 11 and 10. And what functionality you need to configure this with? Alternate functionality. In some of the other classes, we have configured this pin as input. And similarly, you have configured it as output. But now, what you need to do? You need to configure it as alternate function mode. That is, so what value you should write? You need to write 1, 0. Bit number 11 should be 1, 10 should be 0. So how will I do that? For that, initially, I am clearing these 2 bits. How will you clear these 2 bits? Tilde 0, 0, 0, C0. That is, this is known as C0. 0, C, 0, 0. C means 1, 1, 0, 0. That means, and tilde is there. Tilde 1, 1 means those 2 bits will be cleared. Bit number 11 and 10 will be cleared. Then what you need to do? You need to set bit number 11. How will you set? You need to or equal to, previously it was r equal and equal to tilde. Wherever 1 is there, that bit will be cleared. Here I am writing or equal to 80. That means it is 1000. That means 11th bit you are setting, 10th bit you are clearing here. So by doing these 2 steps, you are enabling alternate functionality mode for PA5. Right? So in this step, you are configuring the functionality of PA5 with the alternate function mode. In the next step, we are configuring which alternate functionality you need to use. Right. So we have seen that all the pins are having A0, alternate functionality 0 to alternate functionality 15. Maximum, most of the pins can have these many alternate functionalities. So for configuring alternate functionality 0 to 15, for port pin 0 to 7, each ports will be having 16 pins maximum. So those pins in that 16 pins, 0 to 7 pins are configured the alternate functionality by using AFRL 0 to 31 bits. Alternate functionality register, low register. Alternate functionality, low register. So 0 to 31 of AFRL, L stands for low, is used for configuring alternate functionalities of pins from 0 to 7. Similarly, alternate functionality of pins from 8 to 15 is configured by using alternate function register high 0 to 31. Right? So alternate function register high bit number 0 to 31. This register is used for configuring alternate functionality of pins 8 to 15. But alternate functionality register low is used for configuring alternate functionality of pins from 0 to 7. So in my case, I need to configure the alternate functionality of PA5. So which register I need to configure? Alternate functionality register low, because I am going to configure PA5, right? But you need to keep in mind, before configuring the alternate function register, mode selection register of the appropriate corresponding pin should be configured with the alternate function mode that we have already done in the previous step. So without configuring this mode, whatever value you are writing in AFRL or AFRH, it doesn't matter, right? So before configuring these two registers, GPIO mode register should be configured with the alternate function mode. So this is the alternate function low register. This is used for configuring so this is the alternate function register low. This is used for configuring the alternate functions of pins 0 to 7. Right? So each pins alternate functionality can be configured by using 4 bits. So pin number 0 of any port, say if you are taking GPIO-A, pin number 0 of GPIO-A or port A is configured by using initial 4 bits, that is bit number 0 to 3. These 4 bits are used for configuring alternate functionality of PA0. Why 4 bits? Because 15 alternate functionalities can be configured. That is why 4 bits. Next 4 bits are used for configuring alternate functionality of PA1. Next 4 bits are used for configuring alternate functionality for PA2, like that. So in my case, I need to configure alternate functionality of PA5. So I am taking bits from 20 to 23. So it is written AFRL5. That means these 4 bits are used for configuring the alternate function of GPIO A5, that is PA5. So bit number 20 to 23 you are configuring. With what value I need to configure? 0001. Why? Because in the previous step we have seen that in this table we have seen that PA5 alternate functionality 1 corresponds to timer to channel 1. So timer to channel 1 is alternate functionality 1 of PA5. So I need to configure alternate functionality 1 for PA5. So how will I do that? For configuring alternate functionality 1, you need to write 0001. Right. So I need to configure alternate functionality 5 of, that is for PA5 with 0001 value. 0001 value. That means we are configuring PA5 with alternate functionality 1. So how will I do that? AFR0 and equal to. And equal to means you are clearing, first of all you are clearing these 4 bits, right? 1111 tilde, right? So you are writing 1111 to bit number 23 to 20. That means you are clearing 23 to 20 in this step. In the next step, you are writing this value of 23 to 20 as 0001. So you are performing OR equal to, so wherever 1 is there, only that will be set. So by writing OR equal to 00100, you are setting 20th bit as 1. All other bits are already 0. So by doing this step, you are configuring alternate functionality 1. That is, you are configuring PA5 with alternate functionality 1. What is that alternate functionality 1? Timer to channel 1. Right? So now we are going to generate event in this channel. So PA5 is configured as timer to channel 1. Then This step onwards, we are going to configure the capture compare mode. So the first register you need to configure is CCMR1, that is capture compare mode register. So for almost all the timers, there are two capture compare mode registers, that is CCMR1 and CCMR2. CCMR1 is used for configuring channel 1 and channel 2 for almost all the timers, and CCMR2 R2 is used for configuring channel 3 and channel 4 of whichever timer is having 4 channels, with 4 channels. So now I am going to configure channel 1. So I need to select a register CCMR1. And in this channel, in the CCMR1, I told you we can configure channel 1 and channel 2. So bit number 0 to 7, these bits are used for configuring channel 1. You can see in all bits 1 is written. You can see here. Similarly, bit number 8 to 15, this part is used for configuring channel 2. In my case, I am going to configure channel 1, that is timer X channel 1. So I need to configure only bit number 0 to 7. Again, this register is used for configuring capture as well as compare mode. In my case, I am going to configure compare mode. So again, you can see that in each bits you can see two divisions are there or two rows are there. This is first row, second row. So the first row corresponds to the pins or bits which are used for configuring compare mode. The second row corresponds to bits which are used for configuring in capture mode. So first row bits corresponds to compare mode, second row bits corresponds to capture mode. And here bit number 0 and 1, this is common to both the capture and compare. 0 and 1 is common to both the capture and compare, and the first row corresponds to bits used for configuring compare mode, second row it is used for configuring capture mode. Right. So we are going to see one by one. 7th bit, let it be 0. Then bit number 6 and 4, 6 to 4, that is 654. It is known as output compare 1 mode bits. Output compare 1 mode bits. Why this 1? Because you are going to configure channel 1. If you are configuring channel 2, this part you need to take. So instead of 654, you need to take 14, 13, 12. That is output compare 2 mode register. So based on the channel, you need to select the CCMR1 or CCMR2, and which half you need to configure also you need to decide. So this half is for channel 1, this half is for channel 2. So here I am configuring output compare 1, 1 stands for channel. So this is the mode selection bits for compare mode of channel 1. This is the mode selection bits of compare mode of channel 1 of timer 2 in my case. Right? So here these 3 bits, what all values can be written? If you are writing 0, 0, 0, it will be frozen. That means nothing will happen. You can write it as 0, 0, 1. It will set channel 1 to active level on match. So similarly, 8 combinations are possible. But here I am going to select 0, 1, 1. That means what does it mean? Your channel 1, timer 1, channel 2 will be toggling when the timer counter value is equal to CCR1. Right? So when the timer counter is equal to CCR, we can see that the timer 1, channel 1 will be toggled. Right? So why CCR1? Each channel is having corresponding CCR register. So I am configuring channel 1. So I need to compare, the timer counter will be compared with the capture compare register of channel 1, that is CCR. So when the counter value is equal to CCR1 value, the timer 2 channel 1 should be toggled. That is OC1 pin, actual OC1 pin should be toggled. That is output compare pin should be toggled. So I need to write 011, where in bit number 654. So I am writing TMR2 CCMR1 equal to 0x30. 30 means it is 0011 That means 6 to 4 you are writing 011. That is a function of compare mode selection bits. Then in the same register, next bit number 3, it is used for output compare 1 preload enable. Right, it is preload enable for one register for first channel. So preload register means it is nothing but a shadow register, or it is nothing but a register which is acting as a shadow register to the actual counter register or CCR register, right? So whenever you are writing into preload register, that value will be taken to the capture compare CCR1 register only when the next update event is occurring. So when you are writing a value, you are writing to preload register. The value present in preload register will be loaded into the actual CCR1 shadow register only when one update event is occurring. That means when the overflow, when it is overflowing from maximum value to 0, when that is occurring, then only the loading will take place. But in my case, I don't need this preload register. Whenever I am loading a value to CCR1, immediately CCR1 should be reflected, right? If preload register was there, immediately the value will not be reflected in this register. Whenever new update event is occurring, that means whenever the timer counter is overflowing from maximum value to 0, then only the new value will be loaded to CCR1. But in my case, I don't need that. Whenever I am changing the value of CCR1, immediately I should change it. So preload register should be disabled. So timer 1, CCR1 can be written at any time the new value is taken into the account immediately. Whenever you are modifying the value, it should take into account immediately. The value should change immediately. So prescaler register or preload register, not prescaler, preload register, I am writing it as 0. I don't need preload register. That is what I am configuring here. So preload register I am writing as 0, third bit. Then again in the same register, bit number 0 and 1. What is this 2 bits shows? This is capture or compare 1 selection register. So if you are writing 0, 0, CC1 channel will be configured as output. If you are writing 0, 1, it will be configured as output, it will be configured as input, and IC1 is mapped to TI1. So like that, 4 combinations are possible. But in my case, I am going to generate a particular waveform in timer 2 channel 1. What is that waveform? Whenever the timer counter value is equal to CCR1, you need to toggle that pin, right? That means the last class program, you are going to do an LED blinking program in 1 second. That means whenever 1 second is over, you will toggle the LED pin. The same thing what you are going to do here using timer 1 in compare mode of operation, right? That means you need to generate a particular waveform in timer 2 channel 1. So if you want to generate a waveform in a particular pin, or if you want to generate a logic 1 or logic 0 in a pin, that pin should be configured as output because you are going to generate, right? So what value you should write in this capture compare selection register bits? In the bits CCS bit, you need to write 0, 0. So if you are writing 0, 0 here, CC1 channel will be configured as output. So you can see here bit number 0 and bit number 1 will be written with 0, 0. So you have configured timer 2 channel 1 as output. Similarly, if you want to configure any other timers or any other channel, you can use CCMR2. Till now we are seeing CCMR1 because you are using channel 1. Similarly, for any other program, if you want to use channel 3 or channel 4, you need to configure CCMR2. So the half initial 8 bits will be used for configuring channel 3. Next 8 bits will be used for channel 4. Here we are not using it. We are only configuring channel 1. Next we are configuring another register known as capture compare enabled register. Enabled register. So only 3 bits are used. So the enabled register, by using the single register, you are configuring some parameters of channel 1, channel 2, channel 3 and channel 4. You can see CC1, CC2, CC3, CC4. But here I am going to configure only channel 1. What all configuration I am going to do? CC1 enable. From the name itself you will get it is used for enabling the output of capture compare 1. Previously you have configured channel 1 as output. In this step you are enabling the output, or you are enabling the channel. What value you should write in bit number 0? You need to write 1. When you are writing 1, you are actually enabling the channel 1. You are making it as on. That means output compare for channel 1 signal is output for the corresponding pin. That means you are enabling the channel 1 of timer 2. You need to write 1. Right? Then the first bit, it is known as the polarity selection bit for channel 1. What do you mean by polarity? When you are starting generation of the waveform, whether that pin should be active high or active low. Right? That means you are initializing that pin to 1 or 0 at the starting of the waveform generation. That is what you are doing here. So you are writing 1 here, 0 here. What does it mean? Initially, before starting the waveform, make channel 1 pin as active high. That is 1. So before starting of the waveform generation, you will be initializing channel 1 pin to high. So what value you should write here in polarity? 0. Then the third bit you are configuring, that is NP bit, that is output polarity bit. Right? This bit should be, this is NP, this is P. Right? So this bit should be always cleared once if you are going to configure compare mode of operation. Right? So these bits can be configured for both the capture mode and compare mode. Whatever I have shown here is only the configuration for the compare mode of operation. In capture mode, if you are configuring some value in bit number 0, it is having another functionality. Right? So that is why it is written for CC1 channel configured as output. That is, when you are configuring compare mode, this is the functionality. Here also when you are configuring compare mode, this is a functionality. Here also when you are configuring compare mode, this pin should be cleared. So similarly, if you are configuring capture mode, the functionality will be varying. So in my case, I need to write the last bit as 1. That means you are enabling the capture compare channel 1, and these 2 bits I am 0, making it as 0 in order to initialize the channel as active high. This is capture compare enabled register. And these are the registers corresponding to CCRY. So I told that 4 channels are there. So each of the 4 channels are having corresponding CCRs. So this Y corresponds to channel number. It will be channel 1, channel 2, channel 3, channel 4. X corresponds to timer number. So X corresponds to timer number. Y corresponds to channel number. Right? So most of the timers are having 4 channels. So each of the channels are having corresponding CCRs. Why you are using CCR in compare mode? Because whenever the counter is incrementing, counter value is compared with the CCR value. So in my case, I need to select CCR1. In my case, I need to select CCR1 because I am configuring channel 1 as in compare mode of operation. So I need to use CCR1 register. It is again a 32-bit register. If you are using timer of 16-bit, initial 16 bits only will be used. But here my timer is timer 2, so 32 bits can be used. Then as the last step, what you need to do, once all the steps are over, you need to make or you need to enable the timer. How will you enable the timer? You need to make the 0th bit of timer control register as 1. Right? So this should be 1. Then what should be third bit? That is 1 pulse mode. 1 pulse mode means timer will be counting only from 0 to maximum value if it is enabled. But here it is not like that way. I need to generate a waveform. So once it is reaching the maximum value, again it should be reloaded with 0 or overflown to 0. So 1 pulse mode I am disabling. So 0th bit, third bit is 0. Then 4th bit is direction. What should be my direction? My timer counter should be configured as up counter. So what value should I write? 0. Because here I am assuming that my counter is counting from 0 to ARR. It will be counting from 0 to ARR, and each time when the timer is incrementing, timer counter is compared with CCR1 register, whatever value you are writing here. When both the CCR1 and timer counter value is equal, we will toggle timer to channel 1. So here what you are going to do, you are going to toggle the timer to channel 1 pin whenever counter is equal to CCR1 register. That is, you are configuring timer 2 in counter mode, compare mode, and whenever comparison is equal, you will toggle the timer to channel 1. So first of all, what you need to do, you need to enable GPIOa clock. For that you are making AHB1 enable R, 0th bit you are making it as 1. Then in the next two steps you are configuring alternate functionality for PA5. Then in the next two statements you are configuring alternate functionality 1 for PA5. What is alternative functionality 1 for PA5? That means PA5 will be configured as timer to channel 1. So alternate functionality 1 for PA5 is timer to channel 1. So PA5 will be configured as timer to channel 1 in these two steps by configuring AFR low registers. So 0 stands for AFR low and 1 stands for AFR high. Here, since I am going to configure PA5, you need to configure AFR low register. Low register is represented by this 0. If you want to configure bit number 8 to 15 alternate functionality, you need to configure AFR1, that is AFR high. Then in this step, APB1 enable equal to 1, that means you are setting 0th bit of APB1. That means you are enabling clock to timer to peripheral. In the last class you have seen. So here we have enabled clock for GPIO because GPIO channel PA5 is configured as timer to channel 1. Here you are going to configure the configuration of timer. So APB1 enable, 0th bit you are setting means you are enabling clock for timer 2. Then we have seen that in the calculation, if I want to generate a 1 second delay, my PSC should be, that is prescaler, timer to prescaler should be 1599, that we have already seen, and my auto reload register value should be 10,000. That is, since you are counting from 0 to 10,000, you are writing 10,000 minus 1. Because if you are giving directly 10,000, you will start counting from 0 to 10,000. So total 10,001 counting will happen. But I need to have only total 10,000. So I am subtracting minus 1. Why? Because counting starts from 0. It is not counting from 1. So the same thing is applicable here also. Here also counting is starts from 0. So I am writing prescaler minus 1. Total I need 1599 PSC and 9999 in the auto reload register. So you will be getting 10,000 counts. Then in CCMR1, that is capture compared mode register 1. Why you are selecting mode register 1? Because you need to configure mode for channel 1 of timer 2. Here you are writing 30. That means you are configuring the output to toggle on max. Timer 2 channel 1 should be toggling when the timer counter value is equal to CCR1 register value. Right. Then you are configuring CCR1 register value as 0. So whenever the timer counter value is equal to CCR1, that means whenever the timer counter value is equal to 0, timer 2 channel 1, that is PA5 pin will be toggled. Right. So without my interference, in the last class what you have done, you are checking for UIF flag, update interrupt flag. Whenever UIF flag is 1, then only toggling will happen. But here, without my interference, toggling will happen by configuring timer in compare mode of operation by configuring CCMR1 and CCR1. So here, whenever counter value is equal to CCR1, that is 0, toggling of timer to channel 1 will happen. So after configuring all these steps, you need to enable the timer to channel 1. How will you enable timer to channel 1? 0th bit of capture compare enabled register should be 1. 0th bit of capture compare enabled register should be 1. That means you are enabling compare mode for channel 1, or you are enabling channel 1. Then timer counter value you are initializing to 0. Right? So once all the configuration of timer as well as the compare mode of operation is over, as a last step only you need to enable timer 2. Why? Because once the timer 2 is enabled, the counter will keep on incrementing. And each count, whenever the timer 2 counter is incrementing, it will be compared with the CCR1. When counter is equal to CCR1, it will toggle the pin. So always enabling of the timer 2 or whatever timer it may be, it should be written as the last statement after configuration of all the required other peripherals, including the timer. So this should be the last statement. When the timer is enabled, timer will keep on incrementing from the next cycle onwards. So this is how you are configuring timer 2 in compare mode of operation, and by using compare mode, this is how you are generating a waveform.